Hi, my name is Kiran Baburaj. Welcome to Career Campus Pro YouTube channel. So today you are about to witness a super clean visualization of the symbol Q using an array. See those two pointers. The red one is our head, always pointing to whoever is first in the line. And the green one, that is our tail, keep track of who just joined the queue. So let's start adding the elements. First we add the A. The peak operation is like checking who is at the front of the line without actually making them leave. Look at our queue, it's filling up with B, C and D joining the queue. Each element takes its place at the rear while our tail pointer faithfully keeps track. This is first in first out. It's time for another peak. Even this time it shows the head element without removing it, the same value A. Alright, now it's time for dequeuing. As the elements leave our queue, watch how the head pointer shifts to the next in the line. One by one, the exact order they arrived and the size of the counter keeps perfect. Now let's see how we can efficiently implement this powerful data structure using the Python arrays. We create a queue class. The constructor initializes an empty array or list and set both head and tail pointers to 0. The isEmpty method uses a clever approach. That is, when head and tail pointers are equal, we know that the queue contains no elements. And our size method simply calculates the difference between the pointers to determine how many elements are currently in the queue. The peek method is used to see who is in the front of the queue without actually removing it. It returns none in an empty case and otherwise returning the element at the head position. Now let's look at the enqueue operation. The method is for adding items to our queue. The implementation is simple, that is, we just append the new L item to our underlying array and increment the tail pointer. Similarly, in the dequeue operation, we first check if the queue is empty using the previously defined method. And for the non-empty queues, we retrieve the item at the head position and then increment the head pointer. Notice we don't physically remove the item from the array. Instead, we simply move the head pointer. This gives us order of 1 constant time complexity of removal operations. So let's summarize the key points. The time complexity of all operations is efficient, that is the constant order of 1 complexity. By tracking the head and tail pointers, we achieve efficient operations without having to shift the elements in the memory. The FIFO principle is preserved beautifully. So this implementation of queue offers an excellent balance of simplicity and efficiency. If you found this video helpful, please don't forget to like and subscribe. Happy coding. Thank you.